Hello all, this is Dr. Srilatha, working as Senior Assistant Professor in the Department of Mathematics in Vallurpalli Nageshwara VIGNANA JYOTHI Institute of Engineering and Technology, Hyderabad. So today I'm going to explain about how to find a rank of a matrix using echelon form. So before entering into the problems, so just first see the step-by-step procedure how to find rank of a matrix by using echelon form. So here is the first step here. First, we need to convert the given matrix into echelon form either by using the upper triangular matrix or the lower triangular matrix using only elementary row operations. So here, whenever we are finding the rank of a matrix, we will use only row transformations. Here, there is no concept of using the column transformation. This is the key point you need to keep in mind, right? Next, after converting this matrix into echelon form, we need to find the number of non-zero rows. So first of all, we'll able to know what is a zero row and what is a non-zero row. If all the elements in a row is called a zero row, if at least one element is non-zero, then we can say that that row is a non-zero row. So here, how to find a rank of a matrix using echelon form? Here we'll be implementing only row operations and we'll be finding the rank which is equal to number of non-zero rows. So whenever we are having total number of non-zero rows, that represents the rank of a matrix in echelon form. So before entering into just we'll solve one problem. So here I'm having the order of the matrix, that is 4 by 4 matrix I'm having in my hand. So I need to find, so the question is reduce the matrix into echelon form and find its rank. So here this is the given matrix. So I'm writing capital A equal to -1, -3, 3, -1, 1, 1, -1, 0, 2, -5, 2, -3, -1, 1, 0, 1. So now my goal is to convert this matrix into echelon form. Since it is a 4 by 4 matrix, in general, I will be giving the generalized matrix that I am taking this matrix as A11, A12, A13, A14, A21, A22, A23, A24, A31, A32, A33, A34, A41, A42, A43, A44. So here I will be representing, this is the columns which represent C1, C2, C3, C4, 4 columns, and here I am representing the first row R1, R2, R3 and R4. So whenever we need to convert this into echelon form, first using this first element, I need to make all the down elements equal to zeros with the help of row transformations. This is first step. Now coming to second step here, with the help of this A22, I need to make all the down elements equal to zeros with the help of only row operations. Next, the third step is with the help of this element, I need to make this element equal to 0 with the help of row transformations. So if you observe here, all the elements, we make all these elements equal to 0. That means number of zeros are in increasing order. So we can find rank of a matrix by taking total number of non-zero rows. Now what is my first step here? I need to implement here applying, with the help of this element, I need to make all the down elements equal to zeros. So what is my second operation? I will need to start with R2 since we are having R1, R2, R3, R4. Now I need to make this element equal to 0 with the help of R1. So what is the operation I will be using here? R2 tends to, so with the help of this R1 element, I need to make all the down elements equal to zeros. So here I'm having R2 equal to 1 and I'm having R1 as 1. So can I make this element equal to 0 by implementing the operation R2 tends to R2 plus R1. And next operation is R3 tends to. Here I'm having 2 and here you are having -1. And now multiply that R1 with 2 here. So that R3 tends to R3 plus 2R1. So that element is going to be 0. Next R4 tends to. minus 1, and here you're having minus 1, R4, minus of minus, it becomes 0. So now A is approximately equal to, so I'm not implementing any operation to the first row, I'm writing the elements as it is, minus 1, minus 3, 3, minus 1. And now implementing this becomes 0. Next. So using this operation R2 plus R1, you have to use whole row, you need to implement that R2 plus R1 elementary operation. Now this element becomes R2 plus R1, 1 minus 3, minus 2, and this is minus 1 plus 3, 2, and this is 0, minus 1. Similarly, third operation, this becomes 0. Now you need to implement R3 plus 2R1 to the whole third row here, so that it becomes minus 5, minus 6. So that becomes minus 11. And here 2 plus 6, 8. And this is minus 3, minus 2, minus 5. Next, implementing fourth row, that is R4 minus R1, that is 0. And this is 1 minus of minus 3, this is plus 4, 0, minus 3, and this is 2. Just we completed the first step, that is with the help of this RA11, I did that below all elements equal to zeros. Next, I need to make with the help of the second row elements, I need to make all the down elements are equal to zeros. Now applying R3 tends to 2R3 minus 11R2, and R4 tends to R4 plus 2R2. We get, now A is approximately equal to, I am not applying any operations to the first two rows, so I am writing as it is, minus 1, minus 3, 3, minus 1, 0, minus 2, 2, minus 1. Now implement the first operation, this is going to be, this is already 0, now this is going to be 0. So by applying the above operation, you will be getting here minus 6, and here my 1. This is already 0. Now we make this element equal to 0. And now apply the above operation R4 plus 2R2. This is going to become 1, and this is 0. We completed the second step. Now with the help of this R3 element, I need to make the down element equal to 0. Now what is the operation I need to implement here? Here in R3 you are having 6, and here you are having 1. Now R4 tends to multiply this with 6, R4 plus R3. We get, now this is approximately equal to, just I am implementing the fourth row here. So I am writing the above all three rows as it is. 0, minus 2, 2, minus 1, 0, 0, minus 6, 1. Now implement this operation here. This is already 0, this is 0. Now this is going to be 0. And now here 0 plus R3, that is 1. If you observe here, the number of zeros in first, that is second, third, and the last row, is it the number of zeros are in increasing order? Therefore, we can say that this is in echelon form. If this is an echelon form, now we need to calculate how many number of non-zero rows are there. Previously I explained what is a zero row and non-zero rows. If all the elements in a row of that matrix, we can say that as a zero row. So if you observe the fourth row here, that is this, at least one element is non-zero. So how many number of non-zeros are there here? Total 4 non-zero elements. Therefore, in this case, the rank is going to become, that is rank of A, which is equal, we denote it as row of A. This is equal to the number of, total number of non-zero rows. Therefore, rank of a matrix is going to become 4. Let's solve another one by determining the rank of a matrix. So this is again the given matrix of order 4 by 4. That I am taking this matrix A is equal to minus 2, minus 1, minus 3, minus 1, 1, 2, 3, minus 1, 1, 0, 1, 1, 0, 1, 1, minus 1. So by keeping the above tips where how we did the previous problem, similarly we'll be doing this one also. So with the help of the R1, I need to make all the down elements equal to zeros. Now R2 becomes, R2 tends to So here in R1 you are having 2. Now multiply this with 2 here. 2R2. So that it becomes plus R1. So that it becomes 2 minus 2. That is going to be 0. Next. R3 tends to again multiply this with 2. So that it becomes 2 R3 plus, sorry, this is R1 plus R1. So for R4, no need to make any operation because by default it is 0. Now this is approximately equal to, I'm writing the first row as it is, minus 2, minus 1, minus 3, minus 1. Now this is going to be 0. Now apply the above operation to all the elements in second row. 2 multiplied with 2, 4, and plus R1, 4 minus 1, that is 3, and 6 minus 3, that is 3, minus 2, minus of, that is minus 3. Now this is going to be 0, and this is minus 1. When you implement 2 R3 plus R1, this is minus 1, 1. I'm writing as it is the fourth row because I didn't implemented any operation to the fourth row. So I completed the first step. Now, with the help of this element, I need to make the down elements equal to zeros. Now, what are the operations I need to implement here? Applying R3 tends to, here I'm having R2 as 3. Now multiply this with 3. 3R3, that is minus 3 plus 3, that becomes plus R2. Next, R4 tends to, again here we're having 1. Now multiply this with 3. 3R4, and this is minus R2. Now continue, move on to next one. Since we did the remaining two operations for third and fourth row, I'm writing the first two rows as it is. Minus 2, minus 1, minus 3, minus 1, and 0, 3, 3, minus 3. So by implementing the above operations, if you observe, so 3R3 plus R2, this is going to be 0. Minus 3 plus 3, this is going to be 0. 3 minus 3, this is going to be 0. 3R4, 3 minus 3, this is going to be 0. 3 minus 3, this is going to be 0. So minus 3 plus 3, this is going to be 0. So now it is approximately equal to, I'm writing the first two rows as it is. Minus 2, minus 1, minus 3, minus 1, 0, 3, 3, minus 3. So all the third row elements are going to be 0 and all the fourth row elements are going to be 0. If you observe the given matrix here, the number of zeros are in increasing order. If the number of zeros are in increasing order, we can see that in that case, this is in echelon form. If this is in echelon form, therefore note how many number of non-zero rows are there. So here, number of non-zero rows is equal to, so this is a 0 row, this is a 0 row, only 2 non-zero rows. Therefore, in echelon form, rank of a matrix is equal to total number of non-zero rows. So here total number of non-zero rows, which is equal to 2. So whatever the problems, we need to find the rank of a matrix using echelon form. So first, you need to keep in mind, we need to use only elementary row operations. There is no discussion about column transformations. We will be using only row operations and we'll convert this into echelon form by using step-by-step procedure. So whatever may be the problem, you need to follow all these steps. I hope you understood this one. Thank you all. Thank you for watching.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.